That is correct. Chi-square analysis, cross-tabulation analysis is also indicating of the TOI, test of independence. You are testing the interdependentness of the IV against the DV and vice versa. So how to do that? Analyze, descriptive statistic, and cross-tab. Okay, the cross-tab must begin with the row and column. Okay, word of cautious. Usually, we are going to set the column must be our DV. Usually lah in medical research, allied health research, or any research that I have been helping people doing it, the column is always be your DV. So what's your DV in this case? Stress. Stress or stress.cat? Very good. Must be putting the categorical variable. Never put the numeric variable here. Otherwise, it become a little bit of error lah. Put your column with the stress.cat. And then what is your IV? My IV will be the gender. Put the gender inside the row. You can put it simultaneously, but I don't want to show with you later on. That one, you do it later on. Put the gender as the row. Put the stress.cat inside your column. Go to your statistics. In your statistics here, you can request following statistical measures. The first one, chi-square. The second one, contingency coefficient. The next one, pi and Kramer's V. And sometimes all the medical officers or public health specialists and whatsoever, our friend in this field also are likely to choose this one, risk. Chi-square, contingency, pi and Kramer's V, and also risk. It's measure the risk for the odds ratio or the relative risk. Depends on the type and suitability of your methodological data. Okay. Word of cautious, contingency coefficient and pi and Kramer's V is what? Is a pseudo R. What is pseudo? Pseudomonas is what? It's a type of protozoan, right? Pseudomonas. Pseudo R is what? A type of R, but it's a pseudo. Yes, correct. When you take the nominal scale here, the contingency coefficient and pi and Kramer's V, this one will generate a pseudo R. R is what? Nature of relationship, got strength and directions. When you click these two, it will produce you some sort of R, but not real R. It's called pseudo R. After that, you click continue and then go to the cells. Inside these particular cells, you might want to ask for the expected. What the computer doing? Computer will give you the observed count and expected count straight away. And then you don't want also to request this one. So you want to request or not? No need lah. No need. Up to you lah. Up to you. I preferably don't request it. But for the sake of this showing off to you, I'm going to tick it because after this we are going to see whether it's expected count less than 5 is existed or not. And then the percentage you click here by column. Okay, have you done that one? Okay, and then you are going to click continue, and then you are going to click paste or okay. I'm going to click paste lah because I want to store all the syntax here. Okay, this one is the number 2, measuring the association. Okay, so measuring IV and DV. So this is what I got. I got the gender times by the stress.cat. Oh my God, something happened. What is happening in my data? Who knows? Let me export it first so that you can clearly observe what I'm talking about. Otherwise, you are in the jungle, you don't understand. What these people said about this data, I'm not sure. Okay. So I want to share with you what happened if your data is not normal and what kind of alternative statistical measures that you can be used. Okay. Please firstly look into your gender. What is this? Star asterisk stress.cat. That's me a cross tabulation test between the stress, normal, or stress between male and female as our factors. So usually I don't request for expected count. Usually I don't request it because I don't want to report it. But today I want to request it. First time in my workshop. Why? Just to show off to you. So that you know this is expected count less than 5, this is expected count less than 5, right? So expected count less than 5, how many already? How many expected count less than 5? Why you say 2? Because 2 cell lah. 1 cell, 2 cell. Yes, that's correct. 2 over 4. How many percent? 50%, right? 50% expected count less than 5. If you don't believe me, you go down here. You see, the SPSS already tell you 2 cell, 50% have expected count less than 5. The minimum expected count is 1.67. Do you know how they calculate the expected count or not? How they calculate expected count is very simple. Using this kind of formula also. The formula for the chi-square is same. Observe minus expected, the power of 2 divided by the expected sum of it. But the difference will be here. Yes, no, A, B. Example, Okay, how you want to calculate? You calculate here as the observed count. So how to calculate the observed count? You calculate lah. This one. 9, 1, 11, 3. 9, 1, 11, 3. So how you want to calculate the expected count? Very simple. You total up everything first. 9 plus 1 is 10. 11 plus 3 is what? 14. 1 plus 3 is what? 4. 9 plus ni is what? What? 20. 20. Okay. So the total is what? 24. So when you want to calculate the E is what? Expected count. To calculate expected count, you must know the formula. The formula is follows. A, B, C. You must know ABC lah. A, B, C, D, E, F, G, H, total. You must know how to read ABC. You know how to read ABC, then khalas, you are going to fly. A, how to calculate expected count for A? A will be calculated as follow. 10 times by 20 divide by 24. This one times this one divide by this one, you got A. B, this one times this one, 10 times by the 4 divided by 24. And then C, this one times this one, 14 times by 20 divided by 24. Oh, majority of you already feel pain in your brain, It's okay. After you do all these things, you will get the expected count. So you just put lah, observe 9, 1, 11, 3, 4, and then you expected count. This one, if you calculate, you will get that one, 8.3. If you don't believe me, you calculate lah. I believe the computer lah, Mr. Izzat. Okay, very good. What you believe in computer is good because the computer is always make the correct decision for you. But the most important thing is you understand the fundamental of analyzing it. Okay, then you find out the Pearson chi-square is 0.549. Can you use it or not? You cannot using it because it's violated the assumptions of the chi-square. Therefore, you might want to use the other, statistical estimates. In this case, usually we are going to use the Fisher exact test. However, you must remember, Fisher exact test do not have any value. Okay. So if you want to report the data set or you want to report your findings, you have to report like this. The chi value is equal to NA lah, not applicable because it's violated. And then your P value will be 0.61. 0.615. You put here is Fisher exact. Okay. Then you reject or fail to reject. You fail to reject null hypothesis. And what is your conclusion? You are going to conclude that there is no, this one should be no, there is no significant association between IV and DV. And what is your conclusion in terms of write-up? You will write something like this. There is no significant association between gender and outcome. Outcome is what? Stress level. Okay. At the level of significance 0.05 where the Fisher exact value is equal to what and the P value. Don't put like this, don't put tanda soal. I'm just showing you example. Very Fisher exact value is equal to Fisher exact value is no value lah. where the p-value, yes, you can just indicate like this, where the p-value is equal to 0.615 in the bracket Fisher exact. Yes. Okay, this is the example. However, usually people are wrongly showing their data in the table. Therefore, I also going to share with you how to make a table for the chi-square. So, table chi-square should be as follows. Okay, table chi-square will be as follows. Okay, you should have the variables. So, in this case, you got the gender, you got the male and female, and then you got the what? You got the stress. Okay, I'm so sorry. This one should be one more above here. Stress should be yes and sorry. Frequency in the bracket should be percentage. And then not stress. No. Normal. Kan? Normal. Normal and stress. Because you want to copy and paste. Normal and stress. Otherwise, you are so difficult to transpose everything back. Okay. Percentage. This one is what? Statistics. And then this one is p-value. So your statistical value, perhaps you can put the asterisk here so that you can put the notes down here. Yes, Fisher. Fisherman friend or Fisher exact? Fisher exact, yes. Then you can put your frequency and also percentage. So F is actually frequency. Just to save up some space. Therefore, you put like this lah. 945. Okay, 945.0. And then the next one, 1155. 1155. Okay, the next one will be 125. 125.0. And then the last one will be what? 7. 7 or 8? Oh, not 7 or 8. It's 3. 3 is 775. Then you put the statistical value should be NA lah, because Fisher exact don't possess any statistical value. It's just giving you some ideas on the exact significance, 0.615. This is how you want to report. If you are reporting the chi-square, then you put the chi value lah. Okay, so far so good or not so good? Then you remove everything else here. And then this is how you want to make a table for the chi-square. So don't forget to put the what? The line there, the line down here, and one line here. Don't forget. This is the format. If you're doing like this, khalas, you are able to fly. If you are so lazy to do it yourself, you can just copy and paste my table lah and use it accordingly. Not a big problem also. Understand? So now